I'm trying to stay calm. It's not easy right now. Just get my camera to rotate. Okay, so my previous design, because I started off with the this thing, hang on, this rotor assembly, this basic thing that was a test jig, it got me on a bit of a stray tangent with the coupling system for the new magnet motor, because right, so the rods system using all these rods is okay for a certain amount of, let me take the bag off. So it took me a long time to print all this and cut all these steel rods. It's a lot of work. And I was thinking, oh, I'll have to give up those bags, it's just no good. I'll go on my Nordic Spirit and yeah, I can't suck on them while I'm talking though. So anyway, I'm not saying there's anything wrong with this design, but the problem with it is the rods themselves, we have flux that bounces from one rod to the next rod, and it's hard to control it, because as you know, when I stick the magnet on the steel coupling sections, we get the get a pretty cool effect on the driving system. And there's no reason why it won't work, but it's cumbersome in the way I made it. So I was thinking about changing the design. I'll show you that in a minute. So let me just move this out of the way, put this biasing magnet on the back, and so I've been making improvements to these segments, and I've really found a sweet spot, but there's a constraint on the design, because I ideally want to fold the magnetism on the ends backwards, and you can't really do that properly without sticking these steel shims on the back to suck the field out that you don't want, using little biasing magnets at the bottom. But there's still a certain amount of flux that's coming out the top end here, which I can't really control easily. So it tends to create some issues. So I was thinking about I'm going to model a new design actually in SketchUp, but I have to get some more 3D filament to 3D print that. Now this segment, I probably should put this in the stand. The new segment I designed has got very little cog back, so when I introduce it into the field, so it's mostly friction. See that? It's mostly friction that was holding it there. Well, as soon as that magnetic field grabs it, we have a perpetual type of thrust on the segment to give us propulsion. So I am going to assemble this, but don't get your hopes up, because I'm not going to take it too far, because I've come up with another idea which I want to build. So as I said, as we introduce this into the field, it kicks ass. It really does. Just see that. See it bounced backwards when it took off. That's the amount of thrust we've got on it. And let me just show you that again. Now, if you watch this carefully, you'll see that this whole thing just goes. It jerks out my hand because it's accelerating this segment. Just watch as we get to the point where it grabs it. We've got very little resistance on it, even gravity will hold it there. So if I back it out a bit, right, watch it jerk. I'm going to hold it very lightly actually, with one finger. You see that? That motion when it moved like that was the driving thrust that we have with this segment. So there's no reason why this won't create a motor, because I've got, as I say, we have I've got a really good arrangement and design for this now. But will it be able to drive a generator? Now that is the question. Obviously not, because I would need loads of these things. I would have to stack multiples of these things to create a motor. And I was thinking about this the other day in bed, and everything was getting to me, and I was just getting stressed out because I'm trying to focus on this thing and I've got other things distracting me right now. So I was thinking about this, and I thought, well, this is going to be extremely cumbersome. It's going to be awkward to design, and I'm going to need a lot of these frigging magnets. So I'll just take this off. And I came up with another idea. Let me just move this magnet somewhere safe, where stick it on the fire with all my other magnets out the way. So I came up with an idea of using a different, I'll do this actually in the previous live stream, but I got really hyped up again, hypertension got a hold of me, and I started to get, I'm not going to go there, just slap myself and shut up. So I was drawing this earlier. So the idea with this is that we have a multiple arrangement of segments which are on a rotary system, and these rotary segments are going to be spinning inside a shell, a stator shell with fixed magnets at strategic locations around the segment. So we basically have one magnet per segment start point. Erase that one because that was too close. We need to have a magnetic circuit. You can't just stick these magnets on and hope that they're going to pull and push at the same time, because you have field collapsing on themselves. So you have to have spacing correctly arranged so that you have a field where you have a pulling force and an exit point where we have, but we don't want the exit point to be a different magnet. We want to use the same magnet as a field that will pull it around, sort of thing. It's hard to explain it, but so with the shell would basically be something like the outside part of my motor, which I designed. But the rotor assembly, with this, we've got the rotor assembly which is inside here. The rotor assembly would consist of a bunch of segments around the inside, and these segments would be pushed along by the magnets. But the segments would have to be, because of the constraint with the existing thing, the magnets would be basically folded. I've got some magnets here, I'm just trying to fold this back a bit. So the magnets would basically be folded a bit like that, so that we have a continuous drive force, and that the end magnets would cancel out the cogging effect. Because when you have the magnets, you get some magnets and you put them like that, and you get a polarized magnet that wants to shoot to that end. So you've got a magnet in your hand and it's sliding along. As soon as it gets to that point, it's actually repelling at that point, because these magnets that are pointing up are repelling on the magnet that's just been pulled along here. So the magnet's pulled along here like a train. It gets to this point, and at that point there, it's being pushed away. So you're no longer being attracted to this point, you're being repelled at this point. And the only way to do that is to really have closely mounted magnets with a minimum spacing. So you have to have very little spacing. Any spacing at all, you're going to have a big cogging problem, and it won't work. So I can't really show that right now with one hand, but I'm not going to put this thing on the tripod because I want to keep it on the charger, and I have to unplug the charger and put this thing in the tripod, then plug the charger in, and that stupid thing comes up on the screen saying, oh, battery charger has been suspended to preserve your battery. Anyway, so I'm just going to try to do this. So I'm trying to keep this short. So anyway, this is what I was going to work on in the SketchUp 3D model. possibly next week. I don't know when. I've got to get some off the filament anyway, and there's no rush. But I just want to design something that's less complicated to build, and it's not going to be. I'm not going to be using loads of iron and rods and everything. The trouble with the rods is the rods are good to a certain point, but you end up with losses. You end up with more cogging, more what's the word? Not, I was thinking about latency. No, I don't know if latency is the right word. I think it's it's drag anyway. But you end up with more magnets to iron type of drag, right? But by just using magnets, we can gain a certain amount of torque and acceleration. So this is why I want to go with that basic design. But I'm probably gonna make something that's not quite as big as these things are, because these are huge. I don't know, but the bigger they are, the more torque you get. That's the thing. So I'm gonna make something that's use minimum plastic, which I can test things out. So, but the other thing is still stuck to the fridge, and I want to get that off at some point, because I am going to build this still. I'm going to put this thing together just to test it, to see if it works. Because I've been waiting for that thing on the fridge to dry, and also I've been dealing with, yeah, not going to say. I've been dealing with other domestic issues, let's just say, right? So I have to get past all that before I can really focus on this. So yeah, just have to bear with me. Alright, so I think that's it for now. We'll talk to you later. We'll try and keep you updated. Yeah, thanks, bye for now.